Have you ever just stopped and wondered how a simple, passing thought actually transforms into an undeniable scientific fact? Well, welcome to this explainer. Today, we're embarking on a journey into the very architecture of human thought itself. I want you to imagine building a grand marble Greek temple, a literal monument to human intellect. You wouldn't just throw a bunch of stones together in a pile, right? No, you'd lay them block by block with absolute rigorous precision. And that is exactly what the ancient philosopher Aristotle did for our minds. We're going to explore his 4 logical levels. It's a pedagogical reconstruction that maps out exactly how a simple, solitary thought evolves into absolute scientific truth. So, here is our agenda for the journey. We'll start with Section 1, Aristotle's logical staircase. Then Section 2, concept and proposition. Next is Section 3, from syllogism to knowledge. After that, Section 4, 2 types of reasoning. And finally, we'll wrap up with Section 5, fallacies and the induction problem. Let's dive in.
Section 1, Aristotle's logical staircase. To really grasp Aristotle's logic, we've got to stop thinking of it as just a flat map or a boring list of rules. It's profoundly architectural. It's literally a staircase, built carefully, step by step, where every single level relies completely on the structural integrity of the level right beneath it.
Step 1 is the concept. Step 2 is the proposition. Step 3 is the syllogism. And finally, Step 4 is demonstration. Keep this full blueprint in your mind's eye because we're about to zoom in and inspect those heavy foundational marble blocks sitting at the very bottom.
Section 2, concept and proposition. This is where the magic of human thought actually gets its start. Because before we can debate anything, before we can prove a grand scientific theory, we have to actually possess the raw materials of thought. At this very first level, the concept, we're basically just asking a foundational question. What are we even thinking about? A concept is just the mental perception of an object, a person, or a quality. It's the smallest meaningful unit of thought. But here is what's absolutely vital to understand. At this stage, there is absolutely no judgment. And because there's no judgment, the idea of truth or falsity doesn't even exist yet. Let's ground this with a classic example. Take these isolated words: human, mortal, Socrates. I mean, if I just walked up to you on the street and randomly said the word Socrates, you wouldn't say, that's true, or that's a lie. It's just a concept. It's isolated. The word itself carries meaning, sure, but it carries zero truth value.
But isolated concepts don't give us truth, do they? We've got to step up to level 2, the proposition. This is formed the exact moment 2 independent concepts are connected in a specific relationship. Aristotle explored this massive shift in his work on interpretation. We've basically moved from isolation to connection.
So if we take our previous concepts, we can form the proposition, Socrates is human. We now have a subject, which is Socrates, and a predicate, which is human. The separate concepts are now firmly linked together. It's like they're structurally bound, just like mortar holding 2 heavy stones in our temple.
And because we've linked them, a monumental shift happens. For the very first time, we can ask, is this statement true or false? This is a dramatic hinge in human logic. The precise moment you connect a subject to a predicate is the exact moment the possibility of truth or falsehood is brought into the world.
Section 3, from syllogism to knowledge. Okay, so we've mastered the simple statement. Now we ascend to the 3rd and 4th levels of our staircase. We're moving from mere claims to actual, rigorous reasoning and ultimately profound scientific knowledge.
Now, watch what happens when we combine multiple propositions to literally force a mandatory conclusion. This is level 3, the syllogism. All humans are mortal. Socrates is human. Therefore, Socrates is mortal. We're no longer just asking if one single sentence is true, we're actively looking at the mechanics of thought itself. The central question here isn't just about truth anymore, it's about structure. Does the conclusion necessarily follow from the premises? Like, if A is true and B is true, does C absolutely have to be true? Think about the last time you debated someone. Did their conclusion actually follow from their premises? This specific question of logical necessity is the driving engine behind Aristotle's great work, the Prior Analytics. So the absolutely crucial point here is that having a valid syllogism simply isn't enough to reach the top of the temple. You can have a perfectly valid argument that is totally 100% meaningless. To reach level 4 and achieve what Aristotle calls true demonstration, which is the whole focus of his posterior analytics, your logic must rest on proper first principles. The premises have to be absolutely necessary and universal. Only then does a valid argument actually transform into real scientific knowledge.
Section 4, two types of reasoning. Now that we understand the staircase itself, we need to look at how we actually climb it out in the real world. Aristotle recognized a critical division in logic, mapping out two fundamentally different paths of reasoning, which completely depend on what our end goal is.
There's a brilliant contrast here. On one side, you've got demonstrative reasoning. Its goal is undeniable scientific truth. It absolutely requires those rigid first principles, its conclusions are strictly necessary, and it's all covered in the posterior analytics. But conversely, we have dialectical reasoning, and honestly, this is how humans actually debate. It starts with generally accepted opinions, not absolute laws. Its goal is to examine questions and test ideas through back-and-forth dialogue, so its conclusions aren't strictly necessary. Aristotle explored this more flexible, conversational style of logic in his work, Topics.
Section 5, Fallacies and the Induction Problem. We've entered the final act of our explainer. We've built this magnificent temple of truth, but what happens when the architecture is flawed? And even more importantly, what happens when we look down at the very dirt the temple is built upon?
Aristotle, you see, wasn't just some guy sitting in an ivory tower acting as a formal logician. His epistemology was deeply, deeply practical. In his sophistical refutations, he asks this brilliant question: why do some entirely wrong arguments seem perfectly right? He realized that logic has to serve a dual purpose. It's not just about constructing valid reasoning. It's equally about identifying trickery, deceptive arguments, and fallacies. Understanding how real thought is formed means knowing exactly how easily it can be corrupted.
Which brings us to what I think is the ultimate philosophical cliffhanger. To have level 4 scientific demonstration, we firmly establish that we absolutely need universal first principles. But wait a second, where do those universal first principles actually come from? You can't prove them using a syllogism because a syllogism needs them to exist in the first place. This is the subtle, monumental problem of induction. Aristotle's entire demonstrative system desperately needs these principles, but it literally cannot fully prove them via deduction.
And that single, unresolved question didn't just fade away into antiquity. It echoed through history. Aristotle's struggle with induction became the very foundation for massive debates by Francis Bacon in the 16th century, David Hume in the 18th century, John Stuart Mill in the 19th century, right up to modern scientific philosophy today. How do we know that our foundational assumptions about reality are actually true? Are we resting our grand marble temple of knowledge on solid bedrock, or just on the shifting sands of human assumption? That is the true beauty of Aristotle's logical levels. They don't just teach us how to answer questions, they teach us exactly which questions we still need to ask.